Welcome to this presentation about HB-Reg for hierarchical Bayes regression, a piece of software from Sawtooth software. In review, regression analysis seeks to relate a series of independent variables or predictor variables to some kind of outcome variable or dependent variable. For example, imagine that we owned a series of coffee stores and we wanted to be able to create a model that predicted coffee sales. And we felt that that was related to the temperature, the average temperature of the week, the population, and the cities where those stores were, and the time of the year. A regression analysis would be able to analyze the relationship between predictor variables and estimate the outcome in terms of weights or betas. We would estimate a weight for temperature, population, and the time of the year as it would predict coffee sales in terms of dollars. Now, most regression analyses that you've probably used estimate betas across all respondents or units of analysis. In other words, they create a summary set of betas for the population. However, with hierarchical Bayes regressions, we estimate betas within each respondent or unit of analysis. Why do we do that? Well, in market research applications, we specifically want to be able to target individuals and how those individuals break into segments in terms of their preferences, because the goal of the marketer is to be able to appeal to individuals and people in creating heterogeneous reach throughout the marketplace and therefore producing better products. So, to make this work, each respondent needs to be able to provide multiple observations. Now, this often occurs in data like conjoint analysis or volumetric choice, but there are other situations as well in market research data. Now, how hierarchical Bayes works is it estimates betas for each respondent by considering not only each respondent's data, but also by borrowing information from the other respondents in the data set. And this permits more stable and accurate estimates for each respondent, whereas before we wouldn't really think that we had enough data at each individual to stabilize them. With that introduction, I'm going to go ahead and introduce how to use the software. First, we've created a data set and we've saved it in Excel, and we're going to save it in Excel into a CSV, comma separated values format. The data set is very simple layout. We have in the first column the case ID, and we have this respondent 1001 who has given us 15 cases. Now, each of these cases is an evaluation of a hypothetical product. A product that is composed of one of 3 levels of brand, one of 4 levels of resolution, one of 4 levels of memory, and a price divided by 100 to scale it nicely for convergence within HB. This column we're going to use as is in the data set as a predictor and independent variable, but these other columns we're going to want the software to be able to break them into categorical or dummy coding as they are nominal variables. The dependent variable is the rating, or how much this person preferred each card as composed of those specific attributes. So the dependent variable is the rating, and the independent variables are the characteristics of the product, and we're going to create for each individual a regression via hierarchical Bayes. With that said, we're going to go over to the HB-Reg software, and we're simply going to open up that data file. We can browse to it, and that data file I've called sample2.csv. I've also included a file of demographics. For illustration, I'm just including a demographic called gender that records whether each respondent is a male or a female. I'm going to add that demographic file, and I can use that as covariates, and I'll explain what covariates are in a little bit. I click the Continue button. I'm going to overwrite a file that I'd created yesterday of that same name. And with that, I'm going to go over to the Variables tab. It reads in the variables and takes these labels from the first row of the CSV file. I know that some of these variables are independent variables, and the software has detected that one of the variables is probably continuous since it had more than just integers. It had decimal places of precision, but I know that my last variable is definitely a dependent variable. Now, for each of these attributes, I can type in what label it has, such as brand A, and I could type in labels for each of my attributes and levels, but there's a quicker way to do it. If I've prepared a labels file in CSV format, I can use this import category labels and values from file icon to browse to that label file and simply import it. And when I do that, the labels come in automatically, and that's kind of nice. Now, the next step is to go over and specify the models. I'm going to create a model that predicts the rating for the cards. And I'm going to do it by adding some independent variables. I'm going to add a few independent variables here. The first one is going to be brand. And I know that brand 4 isn't 4 times as good as brand 1. This is nominal data, so I'm going to need to part worth code it or dummy code it, and the software can handle that automatically. Resolution, I'm also going to code as part worth. Memory is part worth. But price, I'm going to use it the way that I'd coded it, because I felt that the way that I'd coded it in the data file is the way that I wanted it to act in the regression in the independent variable matrix. Now, the nice thing about the software is you don't have to drive blind. It's not a black box. You can preview how the software is coding up the design matrix, from the dummy codes on brands to all the way out to the price, which comes in as user specified as the column, just as I had laid it out in the data file, and of course the dependent variable or the respondent's answers. I can cycle between the respondents to see how each respondent is coded up, just as a preview to keep me informed about what's going on. Now let's imagine that I wanted to recode the resolution, and I really wanted to do it as a linear. I could do that by just going over here and flipping it to a linear, and then I could preview the design matrix again, and now I've seen that it's taken my codes and it has zero-centered them automatically and given them a nice range of 1 unit so that it leads to quick convergence in hierarchical Bayes. But I really don't want to do that for this case. I know that that's going to be a dummy coded. So with that, I can preview some settings I have in hierarchical Bayes. By default, the software is going to do 10,000 initial iterations and then save 1,000 draws every 10th draw over the next 10,000 iterations, etc. One of the advanced settings that I want to do is I want to use covariates. And I'm going to include that variable as that I had for gender, and it is a categorical attribute with 2 categories as covariates. Covariates means that when hierarchical Bayes borrows information across the sample to support or help stabilize, to make more robust the results for each individual, it's going to primarily borrow information within the respondent's cohorts. So males will principally be drawing information from other males to stabilize their estimates. Now, I go over to estimate the models, and it's just as simple as clicking this estimate link. And then the software goes off running. It's very fast software. As far as we know, our hierarchical Bayes regression software is the fastest software in the world for computing hierarchical Bayes regressions. This data set is only going to take us about 3 minutes on my pretty light laptop, which isn't very powerful. Faster machines are going to go much faster. 10 or 12 years ago, one would typically have to wait hours or even days to get hierarchical Bayes regression to converge and to finish, but we go quite rapidly today. As the iterations go, we get some fit statistics and some estimates of heterogeneity, but we can also jump over here to the graph, and we can see how things are converging or not. And this gray area reflects the first 10,000 iterations prior to assuming convergence, and the last 10,000 iterations are those in which we're using the data. And this allows us to visually inspect whether things tend to be stable or not. This is an especially stable data set, as is an artificial data set that we've cooked up. We go back to the statistics tab and we can see how long it's going to take. And we can also look at individual parameters as they are estimating iteration by iteration, and look at the color-coded bar in case we want to jump over to the graphic and relate which of these color-coded series relates to which particular part worth. A couple more minutes have now gone by and the software is finishing up the 20,000th iteration. And as it finishes, it writes the utilities, not only the point estimates or the averages across the draws, but the draws themselves into a zipped folder. What's really nice about the software is it zips it up, because the draws files can become particularly large in the covariances file, and we don't want to take very much space on your hard drive if we can help it. Now, it stores it in a way that you can look at, and you can get a run manager, And I ran this run yesterday, and this is the one that we just completed this morning at 7:16 in the morning. And I can highlight it and look over here at some of the settings so I can remember what I did this morning that led to this run. It gives me a summary of how I set things up and a little summary report of how the summary statistics were looking. But more than that, I can export the data out of this particular saved run in this run manager, and I might want to export the point estimates to a CSV file so that I can look at them and do further analysis. I'm going to overwrite the one that I had done yesterday, and if I go out to my folder and I pop that data file open, that point estimates, I can see this is what we've just estimated. For each case, I get an R-squared, or the fit statistic, and then I get the parameters for those for that respondent. For example, the last parameter is the price sensitivity, and we should expect that as price goes up, that the preference for the card or the preference for the product concept will go down. And you can see that these parameters tend to be generally negative for people. We could take this data out to a conjoint simulator or out to perform cluster analysis or segmentation or other types of analyses that we might envision. Anyway, we thank you very much for this brief introduction to the software. We hope you like it.